So you wanted to learn about the atmosphere. Cool. Or did you already know about the atmosphere and you wanted to fact check us? Also cool. Let's get into it. The atmosphere is a thin layer of nitrogen, oxygen, argon, and trace amounts of other particles that surround the Earth. Simple, right?
Right? Wrong!
Then how come a graph of temperature looks like this? Why do we see four different slopes instead of one? The answer lies in how each layer is heated. Let's start from the bottom. Most of the surface heating comes from the sun. How? A famous historian once wrote,
The sun is a deadly laser.
and for the most part, that's pretty accurate. The sun is constantly radiating energy at insane levels. This incoming solar radiation, or insolation, not to be confused with insolation, hits Earth's surface and warms it up. This heating is responsible for the curve up to 17 kilometers high, otherwise called the troposphere. The temperature decreases in the troposphere about 6.5 degrees Celsius per 1 kilometer in height. All of human civilization resides in the troposphere, with Mount Everest only reaching about 8.8 kilometers in height. 35 kilometers above the surface, there's a high concentration of ozone, a whopping 8 particles per million. Despite this seemingly low concentration, ozone still has a massive impact on the stratosphere. This ozone exists in the stratosphere because of the reaction of carbon monoxide and oxygen being catalyzed by nitrogen dioxide. Ozone is able to absorb higher radiation because of its chemical structure. It has a permanent dipole moment, which means it has more kinetic freedom. This energy is emitted from the ozone as heat, which is why the atmosphere has a spike in temperature around 35 kilometers up. The stratosphere is from the top of the troposphere to this heated zone. The mesosphere is from this heated zone to the base of our next layer, the thermosphere. The thermosphere is a dizzying 85 kilometers above the surface, where again, we have heating from the top. Remember insolation? A significant portion of high energy insolation, like gamma rays, is absorbed at the thermosphere, which accounts for its observed increase in temperature. However, interestingly enough, if you were to travel to the thermosphere, the temperature you'd feel would be much colder than the measured temperature because the pressure is extremely low. That low pressure means there are not enough gas molecules to sufficiently transfer the heat to you. So that's the atmosphere, but let's talk about global warming because it'd be a crime not to. It's simpler than some might think. Humans create more CO2, which ends up in our atmosphere. Radiation with shorter wavelengths from the sun hits the surface, loses energy, and then reflects back into the sky with longer wavelengths. The CO2 that was emitted then reflects this long wave radiation, causing it to travel back to the surface and reheat the Earth. Think of the atmosphere as an enormous filter. Radiation with wavelengths of 400 nanometers or smaller can get in no problem, but infrared radiation with longer wavelengths is too large and is caught. This means radiation can enter the atmosphere more easily than it can leave with the presence of gases like CO2. This mechanism causes net warming. Congratulations, you now know more about the atmosphere than your average US politician.